What is transformers? So we know the AC generator and AC motor tend to be simpler than the DC generator and DC motors. This reliability simplicity translates into greater reliability and lower manufacturing cost. But what is AC good for? Surely there must be more to it than the design of generators and motors. Indeed there is. There is the effect of electromagnetism known as a mutual induction, where two or more coils of wire placed so that the changing magnetic field created by one induces a voltage in the other. If we have two mutually inductive coils, we energize one coil with AC, we will create an AC voltage in other coil. When we used as such, this device is known as a transformer. The fundamental significance of transformer is its ability to step voltage up or down from the powered coil to the unpowered coil. The AC voltage induced in the unpowered secondary coil is equal to the AC voltage across the powered primary coil multiplied by the ratio of secondary coil turns to the primary coil turns. If the secondary coil is powering a load, the current through the secondary coil is just opposite. Primary coil current multiplied by ratio of primary to secondary turns. This relationship has very close mechanical analogy. Use torque and speed to represent voltage and current respectively. If the winding ratio is reversed so that the primary coil has few turns than the secondary coil, the transformer step up the voltage from the source level to higher level at the load. The transformer ability to set up AC voltage up or down with easy gives AC an advantage unmatched by DC in the realm of power distribution figure below. When transmitting electrical power over long distance, it is far more efficient to do so with stepped up voltage and stepped down currents, smaller diameter wire with less resistive power losses. Then step the voltage back down and current back up for industry business or consumer use. Transformer technology has made long-range electric power distribution practical without the ability to efficiently step voltage up or down. It would be most prohibitive to construct power system for anything but close range within a few miles at most. Use as useful as transformers are, they only work with AC, not DC, because the phenomena of mutual inductive relies on changing magnetic fields and direct current can only produce steady magnetic fields. Transformers simply will not work with the direct current. Of course, direct current may be interrupted pulse through the primary winding of transformer to create a changing magnetic field, as is done in automation ignition system to produce high voltage spark plug power for low voltage DC battery. But pulsed DC is not that different from AC. Perhaps more than any other reason, this is why AC finds widespread applications in power system over the world. DC stands for direct current, meaning voltage or current that maintaining constant polarity or direction respectively over time. AC stands for alternative current, meaning voltage or current that changes polarity or direct respectively over time. AC electromechanical generator known as alternators are of simpler construction than DC electromechanical generator. AC and DC motor design follows respective generator design principles very closely. A transformer is a pair of mutual inductive coils used to convey AC power from one coil to other. Often the number of turns in each coil is set to create voltage increase or decrease from the powered primary coil to unpowered secondary coil. Secondary voltage, primary voltage, secondary turns, primary current, primary turns, and primary seconds.